Okay, so welcome to week 14 with chapter number 8, project quality management. This chapter will handle the one of the important knowledge areas in the project management framework, and we will talk about the processes and some of the techniques that you can use in these. But first of all, let us talk about what is project quality. There are many definitions there talking about the quality. What is quality? And they look at it from different perspectives, from different disciplines. Here I kept some of them, and they're from the book. The International Organization for Standardization, the ISO, I think you hear this all the time, or you read it on many of the products that you buy daily, even the milk or the grocery that you buy. In many of these products you will find like an ISO 9000, 2000, and something like this. Okay, 9001. There are many standards there. So this organization, they define quality as the degree to which a set of inherent characteristics fulfill requirements. There are some requirements. If you fulfill them, then you are considered as a quality product or a quality process if you have a process. This is one way looking at the quality. Other experts in defining the quality also had these definitions or main say component in your products. The conformance to requirements. The project's processes and products meet written specifications. So if you are producing a car, for example, then the car, there has to be requirements. What do you require in a car? Okay, and then how you produce that car. So the process has to follow some kind of specifications written, and also the product has to meet some certain specifications, some requirements. This is the conformance. So conformance is part or a key aspect of the quality. Also, there is fitness for use. And this is a little different than the first one. This is a product can be used as it was intended. Now, maybe you follow the standard or you follow the specifications, the written specifications, but when you come and you use the product, you cannot use it. Then it does not fit the intended use or purpose of that product. So here, this is what we call the fitness for use. Okay, so it's not just to meet the requirements, but also we can use that product or outcome. And in computers or in the IT field, we follow both. We need to have conformance to requirements, to specifications, and also we need to produce a product that fit to the use, the purpose. Okay, and if you remember in the when you develop your project, you develop the project charter. You mentioned some of the quality in the project charter or the expected outcome, that it has to be also according to the specifications or requirements required from you. What is project quality management? Now, project quality, now we know what is it. What is the project quality management? And basically, it is the process of ensuring that the project will satisfy the needs for which it was undertaken. And we started a project, we had plans, we had execution, and all of these things that we covered earlier, the scope, the time, the cost, and everything. Okay, all these, you have to ensure during this project that you satisfy all of these plans and the execution is done according to these plans. Okay, you don't divert from these plans. Okay, so this is what we do. And here we are talking about three main processes in this process. The first is planning quality management, and it is here about identifying which quality standards are relevant. Okay, you might follow ISO, you might follow the IEEE, you might follow, it depends on your industry, which field you are working in or discipline. Each field or each industry have their either you go for something standard like ISO, or you have something specific like the IEEE, for example. So in computers, we use, in software development, we can follow the IEEE standard. And in engineering, they have some standards to follow. In accounting, they have standards like IFRS. In USA, they have the general accepted accounting principles, the GAAP. You can also use them as standard. So it depends on the industry that you're working in, or the uh, discipline that you are working in. So you need to identify which standard you are going to follow, okay? And you plan for how you are going to satisfy these standards, okay? And usually we have some kind of like measures or metrics. And metric is a standard of measurement. Yani what is the metric used? So for example, when we want to weigh something, then we have to follow a standard measure, and this standard a metric. So this metric could be either kilogram or pound. Okay, if you want to measure say the length, okay, you can go for meters or centimeters, or you can go for something like yards or foot or something like this. So this is the this all set and defined in the planning of the quality management. And from the name, you know that this goes under the planning stage. Then you have performing quality assurance. And performing quality assurance comes in the execution, when after planning, after you started working on your product development or on the system development, you want to ensure that you are performing the work up to the standard. Okay, so you do a periodic evaluation over all the project performance to ensure that the project will satisfy the relevant quality standards. Okay, and here now, there in the beginning, we planned for that. We selected or defined the standard and the metrics. But here, when you are working, you need to evaluate the performance to see if you are really following the quality standards that you used. Then in the third process is performing quality control. This goes under the monitoring and controlling phase. And in this process, we monitor specific project results to ensure that they comply with the relevant quality standards. So here you see you want to ensure that the results comply to the standards that you already adopt in this project. Okay. Here you can see the summary of these processes, and you can see that there are three and distributed based on the phases: planning, executing, and monitoring, controlling. And these are the outputs. So here you have the quality management plan in the beginning, and the first process. The output also could be process improvement plan, because we can also make sure, or we can make quality help us to improve our processes, the way that we produce and the way that we work in projects. Okay, we have also quality metrics, quality checklist. All these has to be prepared in the planning process. Then in the quality assurance performance you will have while executing. There are some problems in the execution or in the product, okay, while executing. Then you start to kind of like rectify these problems, and any change to the products also need to go to the same procedure that we always talk about, which is the change request. If you want to change in the design because the design was not properly designed or something or documented, then you have to go and do it there. We will come to this inshallah in a minute, in the coming slides, and other updates to the plans and others. The monitoring and controlling, you also you perform quality control by having measurements. So the output will be measurements of the output, validated changes, and some changes has to be validated, and then got approved through the procedure, and then you will have validated deliverables, and the deliverables are checked if they are according to the plan or not, and so on. And also the work performance information, which is something that you will produce when you are executing, and any other update after a change happens, you have to also include them. Okay, if we take the first process, planning quality, and this implies the ability to anticipate situations and prepare actions to bring about the desired outcome. So you want to, because you are planning, so you didn't start working now, so you have to try to expect what situations can happen, what problems, what defects can happen in the product while you are working or you are producing the product. Okay, and based on this, you put the measures that you want to ensure, or the checkpoints to ensure that these things, these wrong or defects cannot happen. Okay, so you try to prevent them. Here are some examples of how you can prevent defects in your product or your outcome of the project. The first thing is selecting proper material, because if you select poor material, something cheap quality, then the outcome will be also poor. So here the defect will be the probability to have defective product will be high. And you can see this in when now when we know that we always have this Chinese products are cheap, okay, in price, and we also know that the quality of these products are also it's not that good quality, okay, so cheap also, because we say also cheap quality now. So what we mean here is that because these Chinese companies, their strategy is to provide you with a very cheap product, and to provide you with this cheap product, they need to buy or use very cheap material, and cheap material doesn't have, it's not strong enough, it's not durable. Okay, so they will use these just to provide you the product, but the duration, the reliability of the product will be questioned because they used something very cheap. Okay, it's not up to the standard. Okay, so if you want quality product, then you need to ensure that the ingredients or the material that you're using is proper for the use of that product. Also, you need to train and teach your people who work in this project about quality. Let them understand what is quality and what is the consequences of not having quality products. Okay, imagine that you produce cars, okay, and your team doesn't understand what could happen if they produce bad braking system. Okay, so you need to let them understand and know what this could cause. Very dangerous accidents might happen, lots of costs, and maybe lawsuits will be filed against the company and all these things. Then they will say, okay, we know that the consequences are not something easy, so on the company if it happens. So we need to make sure that we produce good quality, defect-free product, and like this. Okay. Also, to prevent defects is to have good process. You need to ensure that your processes are planned well and designed well, so that the way that you produce the uh, product ensure that it has high quality and conforming to the standard, okay, and the outcome of your work. So this is also important. If we look at the scope of any project, especially in IT projects, the aspects that we look at and we want to ensure the quality of are these, and these are some examples, but these are common. For example, functionality. And here, functionality means that it is the degree to which a system performs its intended function. Yani if you write a code for a function, for a software to do some certain function, it has to do that function. If it doesn't do it, then, for example, printing reports, annual reports for financial system. If the system that you coded or constructed cannot print these annual financial reports, then it's not giving the functionality that you want. So the quality here is questioned, okay? Then you have the features, okay? Features are the system's special characteristics that appeal to users. I want a system that helps me to organize my files. I want a system to help me to organize my budget, or to forecast the sales of the. So if these features are not there and I wanted them, then the quality is also considered as not conforming to the needs and the quality. So you have low quality, or you didn't meet the quality standard. System outputs are the screens and reports the system generates. Also, the output of the system, how the interface will look like, what are the reports that you are generating. These are also what are the expected output. If you don't meet them, then again you have problem in the quality. Performance, this is how well a product or service performs the customer intended use. Again, here related to the performance. The system works, but it's not capable to handle the large volume of orders, for example. Then this is a problem. Okay, so the performance is important. You need to handle the customers' orders as intended, so that you can say that this product is performing well and it meets the standard or the quality. Reliability is the ability of a product or service to perform as expected under normal conditions. Reliable إنه يعتمد عليه. Okay, you can depend on this system. Okay, when you generate some kind of reports, some kind of calculations, these calculations are reliable and it is correct. Okay, so you every time you generate these reports and generate these calculations, it will give you the right result. Okay, then we have maintainability, and this is the ease of performing maintenance on a product. Also, part of the quality is that when you create your system or your product, you need to ensure that it is serviceable or it is maintainable. You can maintain it. Okay, you can correct the problems. Okay, imagine that you develop or you design or you manufacture actually car, and this car doesn't have the option, or you cannot open the engine to change the oil. Then what will happen after driving the car for more than 10,000 kilometers? Then the engine needs to change the oil, but you didn't design the engine to be opened and to change the oil. So what will happen? Your engine will blow, and then you need to replace the engine. So maintainability is important in your to address in your product or in your system, so that you meet the standard again, and you meet the quality standard. Okay, similarly for the IT projects, if you have a system that you cannot change the reports, for example, or you cannot modify the reports, or you cannot change the codes, then you cannot maintain it. Then you have problems also. Now, who's the responsible person in a project about the quality? طبعا, the ultimate responsible person is the project manager. At the end, he's responsible for all these quality issues. So he needs to ensure that he covers everything. And to cover everything, it's difficult. And if you rely on a person's judgment or expertise. So what we do is, and we talked about this in the first chapter that we talked about in the semester, we talked about the best practices and the standards. So here, if you follow a standard, okay, then the chance that you make mistakes or you miss some quality issues, is less. So there are the most known standards are the ISO, okay, which is generic, but they have some kind of specialties. And we have in the IT field, we have the IEEE, okay, standard. And also this is it is followed by many of the software development and product, computer development or manufacturing companies. The second process is performing quality assurance. Quality assurance includes all the activities related to satisfying the relevant quality standards for a project. So ensuring that all the activities are satisfying the standard. This is the quality assurance. And I just mentioned this. The quality assurance will also help you to improve the quality of your process or your product. So this is kind of like a continuous quality improvement. You always improve the way that you used to produce or to do the work, and the quality of the product also will be and this will be reflected on the product that you are producing. Benchmarking. We talked about this earlier in the scope management. Benchmarking is comparing yourself with other projects, other organizations, other features and products. So how this help the quality? Because you try to compare your quality, the quality of your practices, or the quality of the system that you are developing, or the product that you are producing. You compare the quality of this of yours with others, with other organizations or with the industry, okay? And this is also done to ensure that you reach to the quality standard, and also to improve yourself. If you see that your products or your processes are less or lower than what is applied in your industry or with your competitors, then you try to improve these processes and improve the features that you have in your product. Also, we conduct the quality audits, and these are kind of like structured reviews for specific quality management activities, which will help you to identify lessons learned. And again, this will help you to improve the performance on your project or for future projects. These usually lessons learned are produced at the end of the project. So maybe it won't be helpful in your project, but it will help in the future projects that you are going to conduct. The third process is controlling quality. Now, controlling quality focus on the output mainly, okay, and the results of the execution. So here, when you produce, whether it is the full product or even during the product development, like parts or stages or some kind of portions of that final product, you need to check these. Now, if you find a problem in the quality, then you have three choices. Some quality issues or defects can be accepted. So you can accept this problem or this defect. So that's acceptance decision. You can accept it. It's okay, fine. And it doesn't affect the functionality. It doesn't affect the safety of the user. Okay, it's just maybe the color is not. The color is not complying to the standard color that we expected. Okay. So you can just say, okay, no problem. We'll just produce this product as it is, and we are going to sell it in the market or give it to the customers. Another one here is the rework. Rework is when you see that this product or this portion of the product or this part produced for this product cannot be used, okay, or it will cause more problems later in the future. So here you have the decision to rework it, to reproduce it again, and this will طبعا incur high costs, especially if it's something expensive in terms of material used or the people who are working in. And also you have the process adjustment. Sometimes you see that you need maybe, okay, you can accept these defects, but you can improve. So what you do is that you adjust the process because we are doing in this way in the wrong way. So we'll just adjust the process so that the coming output will be better than this output. For example, the color, it will be darker. So you just adjust the process and then you make the color darker. And like this. Okay, and for example, if you are baking some kind of like a cake, okay, you kept it for 15 minutes in the oven, and then it became very dark. So, but you can eat it, it's fine. You want it to become not very dark brown, you want it to be golden. So you adjust the process. You say, okay, instead of keeping it for 15 minutes, we'll just keep it for 10 minutes in the oven. So here you adjusted the process. Okay. Now there are many tools there to help you in controlling the quality. I will go through some of them here. It says here there are 7 basic tools, but there are more, and we are covering around maybe 11 or 12. But keep in mind that we don't have much time to go into each of these tools and explain them thoroughly. I'll just go through them quickly just to understand what are these. Okay, so just want to understand them. You can define them. Okay, and if there is something that we need to explain, I will explain it, but I won't go into details because some of them, like the Six Sigma, this needs a complete course only to understand it. Okay, so the first one is the cause and effect diagram. Okay, we call this also the fishbone, okay, or the Ishikawa diagram. And this technique uses this diagram. I'll show you in a minute. It traces the complaints about quality problems back to the responsible production operation. So it's like you see what is the cause. So you see what caused this effect to happen. That's why they call it the cause and effect diagram. And they call it the fishbone because if you look at this diagram, it looks like a fishbone. Okay. So you can see here that you are tracing from training here. Okay, you are seeing what are the probable causes. Okay, in training. So the problem here is that users cannot get into the system. So why the users cannot get to the system? Maybe it is a training problem. They don't know how to use their username and password, or they cannot reset the password, or they always forget their password or something. So these are the causes that might cause this effect. Or it may be there's a system problem or hardware problem. Your servers are not functioning, okay? Or it may be a software problem. Your software is having a glitch or something. So these are the causes. Or it may be user's hardware, okay? Maybe your client, not the server, the computer that you're working on has a problem in the memory, or there's no disk space or something like this. Or maybe it's very slow. So here, to know this problem, to solve this problem, I need to go back to what causes this problem. It might be software, it might be training, it might be hardware, the system, or the user. And then I look at all of these until I know where is the problem came from. This is the way that you use the fishbone diagram, or the Ishikawa diagram, or the cause and effect diagram. Okay, it has 3 names. It's all the same. Okay, and here say that we always have this, or this technique follows the 5 whys. Okay, so you ask why this happened and why, and it's mentioned, I think. Anyway, we don't want to go through them because I think I don't have the details of this, but you can, if you wish to read more about it, you can, in the book we have more details, and also there are references. You can go back to these references. But what I want you to know from this technique is that how it works, which is tracing the complaints to the source of the causes of it. Okay, and you know the other names for it. Second is the quality control charts, and these are graphic displays of data that illustrates the results of a process over time. Okay, so it's like a timeline, and then you have these like charts, or what do you call these, the columns or bars. Okay, and this will help you طبعا to look at your performance, and to see if there is some defects, or some kind of rejected products, or something. Then you make the decision whether to keep them or to remove them, or to make a decision about these. Okay, so you can, for example, develop a chart. Maybe I think you don't have here a chart showing how many broken, for example, pieces. Okay, so you can see that in the first day they broke, and while fixing something they broke 10. Second day they broke again 10. Third day they broke 15. Now you see that there's something going on. 10 pieces every day, and they are increasing. So then you go back and you see what's the problem. Maybe the tools that they're using is not right, or maybe the material that you produced this item from is not good. So you need to go back and change the production process, and like this. So this is how it helps. Then there is something called the 7-run rule. The 7-run rule states that if 7 data points in a row are all below the mean or above the mean, okay, or they are increasing and decreasing, then the process needs to be examined for non-random problems. If this problem happens only 2 times, and then things went okay, fine, then you don't care about it. But if it goes more than the mean, the average, or less for 7 times subsequently, then you mean that there is a problem. So 7, then you need to go and look at it. Look at this chart. This is an example of the 7-run. Now look at this is it's not mentioned, but I think this is related to here inches. Okay, so I would consider this as, these these sandwiches. Okay, the subs, these long sandwiches. Imagine that you are here, you are producing or baking these sandwiches, and the sandwich has to be 12 inches. Okay, this is the size of that piece of bread. So the mean should be 12. Now, when you are producing, you put more of the dough, so it became longer. Okay, more than 12 inches. It will be 12.02 or 12.07. No? Or you put less of the dough, so it will be less than 12. لا إذا شيء بسيط, it's fine. لا, but you always have to be within the range 12. Now look at these. If in the beginning it was 12 شوية 0.01, something very minor. Okay, then here 2. Okay, then it went down, down. See, it didn't go back here to the mean. Here also became down, 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 down. So if you count these, 1, 2, 3, 4, 5, 6, 7. 7 points. Sorry, 7 points are below the mean. So here, this means that you see this star here denotes violation of 7-run rule. So you stop here, say, okay, wait. Why we having 7 points less than the mean? Why we have this? Then this means that we have a problem. Okay, let's go back to the scale, for example, that you are using, that you are weighing the dough. Okay, maybe there's a problem. It's not weighing it properly. Okay, or look at this. 1, 2, 3, 4, 5, 6, and 7. Now these are, or you can look at them opposite. 1, 2, 3, 4, 5, 6, 7. Okay. Again, they are not within the mean. Okay, so it's going down. They are not 7 below. They are 1, 2, 3, 4, 5, 6 below the mean, and 1 above the mean. Okay, so bad, you have a problem here. Okay, because they are following subsequently. So here you also need to check why this happened again. Okay, and this is how you detect if there's a problem in the quality. Okay, this is the 7-run rule. 4 is the check sheets. Check sheets are like checklists. Okay, used to collect and analyze data. It's sometimes called the tally sheet. Okay, this is an example. Okay, so here you're kind of like taking or counting the number of complaints or number of errors or something like this. So for example, this is about system complaints. Okay, people complain. Okay, now you want to know the source of the complaint, and it comes from which of these sources. Is it from email? Is it text? Is it phone calls? Okay, so here on Monday you got 3 complaints through email and 7 through text, 1 through phone call. Okay, Tuesday you get these, Wednesday you get these, Thursday you get these. Now at the end of the week you look at the total, you see that 29 complaints came through text. Now if you have a help desk center, okay, and you want to know which channel to which is the best channel to receive the complaints, based on this you will know that the text messages are the most used channel for complaints. So here you can make the decision to go for the text channel, or to place more attention to the text channel. If you look at the days, you will see also that Monday, Tuesday, they have the highest complaints, and the rest they decrease until the end of the week. So here also you can say, or you can interpret this by saying that, okay, on Mondays we always receive high complaints. Why is this? Is it because it's the first day in the week? Because this is based on US, and their holiday is on Saturday and Sunday. So Monday is the starting of the week. So is it because people starts the week and they come after the holiday and they forget how to log in, for example, or they forget their password or something like this. So then you can also investigate further. So these check sheets will help you to decide where you can improve or where you can work on. Scatter diagram, and this is another way also to depict the variances or the problems, or you can also show the relationship between two or more variables. Okay, طبعا you can look at this. So here you see that this is the relationship between the age of respondents and the satisfaction. If you look at these, you will see that طبعا 2 is less satisfaction, 5 is higher satisfaction. So if you look at these scattered points, you can see that people who are older has less satisfaction than people with in the 20s. Okay, see the age of 20s, they have more satisfaction. 20 to 30, they have higher satisfaction rates. Okay, while the 40s they have only 3.5 rates of satisfaction. 50s before 60s, 50 to 60, they have from 2 to 2.5 satisfaction rate. So here the scatter diagram will show you the relationship between two things, between the age and the satisfaction, or anything else, but this is just an example. Okay, so this is showing the relationship. Okay, the histograms, and this is similar to the first one that we talked about, the charts. Okay, it will show a graph, a distribution of the variables on a graph, and you can see it here. For example, this is the number of complaints that we received in a week. So in the first day of the week, we received around 76, 75 complaints. In the second day, we have more than 90 complaints, and like this until the end of the week. So this shows us we call this the histograms. It shows us the complaints based on their numbers during the timeline, which is the week. We also have the Pareto chart. Okay, the Pareto chart is a histogram, but it has or it helps you to prioritize the problem areas. And this is about a different topic. We'll not go into detail in it. But Pareto analysis is called also the 80-20 rule. And this rule says that 80% of problems are often due to 20% of the causes. Okay, and this is how you can calculate this using some tools. Flowcharts. Flowcharts are helpful because they display the logic behind a process. Okay, and if you understand the flowchart, if you revise the flowchart and check the logical flow of this flowchart, then you can know where are the problems and you can rectify them. Okay, something like this. Okay. Then you have the run charts. The run charts are similar also to the charts that we discussed earlier, but these are usually used like in this way by comparing different defects or different features. Okay, and again during a timeline. So here, for example, you can see that we have 3 defects that happens when you are working on the product. Now, if you look at the first one with the with this shape, okay, which is this one, you will see that it started in January, and then it was going up and down, and suddenly after May it started to go up. June, July went up, August went up, and then it went. So what this means that this defect number 1, it is increasing during the year. Okay, so here you need to place this defect very close attention. Why it's happening? We have a problem. Maybe one of our equipment is damaged and it's damaging the outcome. Okay, so you need to look at this. Defect number 2, which has this square, okay, which is this one, this line. If you look at it, it started in January having 10 defects, and then it was reducing until it reached to 6 here. So here you can say that, okay, I think maybe you detected the problem and you solve it. So it's still producing defects, but the number only 6. Okay, it's not a big number, okay, of defects, so we can accept this. But see here, you are now more comfortable because it was 10 and became 10. It was reduced. So this means that you controlled it. Defect number 3, which is the triangle, this one, you can see that it is fluctuating. Sometimes it is low, sometimes it is high, okay? And you don't know, this could be something that you don't know how to solve, okay? And if you look at the overall progress or the number of these defects, you can see that it is growing, although it's fluctuating up and down, but overall it is going higher. See, now it's reached to 5 here, okay? So this is also something that you have to keep in mind, or to monitor. So these run charts will help you to look at these defects and analyze their occurrence and see why they are occurring and why it's in May low, in April it was high, okay? Then you can look at the problem, where is it, and you can solve it. We can also use statistical sampling, and this is involves choosing or picking part or sample from population. Okay, so for example, you are producing cars. Okay, let's say 500 cars a day. So you come and select 2 or 3 cars, and you take these cars. We call these sample. Okay, these 3, or let's say 5 cars from the 500. Okay, you take these 5 cars and you test them because they are all produced at the same batch at the same day. No? So you use the same way, the same material to produce that car, these 500 cars. So you pick 500 randomly, sorry, 5 cars from the 500 randomly, and you test them. You drive the car, you test everything in it, and then if they pass all the quality checks, driving fine, everything is okay, then you consider this as the whole batch. These 5 cars are meeting the standard and the quality, so you approve them. Okay, and to choose the sample or to decide the sample size, there are a certain way to calculate this. Here, let's say it gives you one of the samples, way to calculate the sample. Okay, but you can use there are tools that you decide that can help you to calculate the sample size that you require based on given information. You give the population and the accuracy that you are seeking, the confidence level, and all these things, and then it will generate the number. And it will tell you if you want to check the quality through a sample. Okay, then for this population, you need to select 500 or 200 or 100, okay, to ensure that you cover, or this sample is representing that population. Okay, طبعا you need someone to help you in statistics to ensure this is done correctly. Okay, and this is the certainty factors and the confidence level. Okay, so it's statistics. Just skip it. Six Sigma is a comprehensive and flexible system. It doesn't just go through the normal way of inspecting, but it has more in terms of ensuring that the process are improving and they are doing some kind of statistical bad measures and all these things. So the aim is to have a comprehensive, flexible system, okay, to achieve for achieving, sustaining, and maximizing business success. So it links your business success to the process of producing. يعني it has بعد يعني you can refer to this this book here, or yeah, I think, yeah, this book about the Six Sigma way, if you want to know more about Six Sigma. But it's one of the techniques that we use in ensuring the quality of the processes and products that we produce. In Six Sigma, يعني it's one of the very well established techniques, and it is used in many of the organizations. And it is the target of this Six Sigma technique is to reach perfection. Okay, and perfection here means in Six Sigma that if you produce 1 million products, the opportunity of having defect is 3.4. Yani if you produce 1 million cars, only 3.5 cars will have defects. Okay, not more than that. Okay, this is what you try to achieve. And how you achieve this, okay, is because this Six Sigma technique focuses on the process, the way you produce the product. Okay, and they follow a 5-phase process. They call it the DMAIC. Okay, and you can read about it if you want. Also, it will be explained later, further in the book. But you're not required to go through these. Just want you to understand this. Here I'll give you an example. See, if you say 1 sigma, okay, then the percent of population within a range is 68.27. The defect, look at this last column, the defective units per billion, and if you produce billion products, okay, 317 million, 300,000 units will be defected. Okay, if you have 1 sigma range. Then we are talking about the 6 sigma. If you go 2 sigma, then the defect will be lower. 3 sigma, the defect will be lower. If you go to 6 sigma, which is what we expect from the Six Sigma technique, you will have in a billion, you'll have only 2 defects, only 2 units defected. So see this. So this is almost 100%, 99.9999998% of coverage of the units of the population. Okay. And here, this is any more. You don't need to, but this is in 1 million. Okay, the DPMO 3.4. This is the defect that in 1 million, 3.4. This is the acceptable. You don't go more than that, higher than that. Okay. Then also to ensure quality. Techniques also can be one of the techniques that you can use is the testing. You test, especially in IT, software development, we test. And testing, we have stages, not just one type of testing, we have different types. So we have unit testing, where you test each individual component of the program, and you have 5-6 developers working on different parts of that system. So each of them will focus, after writing the code of that part, someone need to check and test this part only as separately. Okay, that it doesn't have defect, so it's defect free. Then you need to join these components. So here you have to do integration testing. Integration testing occurs between unit and system testing. So you are joining all these units, okay, and to check their functionality. They are when they work as together as a set or a group of units. Then you have the system testing. System testing tests the entire system, okay? Not just these integrated modules, but the whole complete system, including طبعا يعني different parts of the system. يعني for example, servers, databases, and everything, not just the coding, okay? Network and all these. Then you have the user acceptance testing, and this is an independent test that performed by the user. So you bring the end users and let them test the system. They use it, they enter the data and generate reports and work with it, put some dummy data, check if it is calculating properly and doing everything else. And then they will accept. If they accept it, then this is also a test that you passed. So that's user acceptance T, we call the UAT. Okay, and this is basically when you خلاص, you deliver the system. Okay, here also this is a diagram shows the testing in terms of the software development life cycle. You can see here that the when you initiating of the project, feasibility of the project, and planning, detailed requirements and architecture, building, whatever, all these. Okay, then when you come to the system design, when you come to development, you start developing. So you develop the system by units. So unit design and then coding. Okay, you test the unit. Okay, go and rectify, and you go again until the unit testing is completed. Then here you have many of them, many units. So then you put all the units together and you do the integration tests. You link them all together, integration test, fine. Then you do the system test, fine. Then you do the user acceptance test, okay? And then طبعا you do the implementation of the خلاص, you implement the system, it goes live, and then you can start using it. Okay, so this is how these types of testing fit in the software development lifecycle. Global issues طبعا, the world is always developing, and we are always having new technologies, advancements in the technologies used. So this will require you to have or to ensure that all these technologies are fulfilling the standards or the safety measures, these things. So here is an example of the car manufacturing. Now, you heard about Tesla, for example, one of the best electrical cars. Okay, and the Tesla is a car that is powered by battery. Okay, سيارة ما فيها engine, ما فيها سيارة كلها battery. Okay, so this car it's a battery, charged battery. So what happens if it blows up or it gives you a very high surge? It's very dangerous. So and it's not just Tesla, many other car manufacturers, they followed also Tesla, and they followed these electrical car or hybrid cars production, and they will all produce cars that use electricity, or they are powered by electricity. So people will start thinking about their safety. Okay, are these cars safe? Okay, so the good thing is that the ISO, for example, has a standard which was updated on safety of cars, and it is made specifically for the electric and hybrid cars, okay, to prevent any kind of electricity related injuries for the users of the car, the passengers. Okay, and it produced the ISO 6469-3 2011 electrical propelled road vehicles, protection of persons against electric shock. This will help طبعا the world to produce safe electric cars. Okay, so the standards are very important to ensure not just the production of the cars or the products without defects, but also to ensure that it doesn't affect the safety of the users, okay, the end users. Okay, now the cost of quality. The cost of quality is the cost of conformance plus the cost of non-conformance. Yani if you confirm to the standard, okay, or the standard or the quality, this means that you have to do some measures, okay. Now Allah, you have to put, for example, safety seat belt, okay. So this is a cost, la. A seat belt, it will cost you. You have to produce seat belts and you have to fix them in the car. You need material, so that's cost conformance of quality. But there is also the cost non-conformance. You know, okay, you produce the seat belt, but you didn't fix it properly, or there's a problem in the seat belt functionality. So what will happen when people drive the car and they hit the brake hard, or they had an accident and this seat belt didn't hold them as expected? Then what will happen? Then they will sue you. They will come and they say, okay, now you have to I was injured, but then you broken my nose because of this seatbelt not functioning. So now you have to pay me. You have to reimburse me for these. Okay. So the cost that you are going to pay to treat these people is the non-conformance cost, because you didn't conform to the quality, to the safety quality. Then you will bear these costs. Okay. So conformance means delivering products that meet requirements and fitness for use. Cost of non-conformance means taking responsibility for failure or not meeting quality expectations. Okay, the braking system of the car did not work. So what will happen? And then you have to take the responsibility. And okay, these people who drive your car and they will hit the brake and the brake will not work, they will do accidents. Okay, they will be injured, they will injure other people. All these you will be responsible about, and then you need to do something about it. Pay some kind of reimbursement or something. Okay. Now the 5 cost categories related to quality. Prevention cost, okay, it's from the name. You will spend some money to plan well and to do and execute things properly, so that there is no problems or no errors in it, so it's error free. Okay, or if there are errors, these errors are within the acceptable range. يعني ما تأثر. This is very normal. Okay, so that's preventing or prevention cost. Okay, you incur these costs to prevent anything wrong happens. Okay, and this usually comes in the planning and execution. The appraisal cost, this is cost of evaluating processes and their output to ensure quality. Yani you bring someone to check the quality of your process, or to check the your equipment. Okay, you have some equipment, you want to ensure that these are fine. So you need to appraise them. You need someone to evaluate the processes or the product. Okay, then you have the internal failure cost. Now, if you have a failure that happened before you deliver the product to the customer, then this is called internal failure cost. I am producing a car and I noticed that, or detected that, the braking system is not working properly. Okay, so what I do is that I fix it. Fixing it means changing, for example, this material, bringing some other material, good material, and fixing it in the brakes. So this is internal failure cost. The brakes failed in the testing, but before I give the car to my customer, so I fixed it. So this cost of fixing it is internal. External failure cost is when you produce the car and the defect is there. You didn't notice that the brakes are not working properly, and you deliver the car to the customer. the customer used the car and they made accident or something, then you need to pay for that failure of your brakes. And that's the external failure cost, okay, because it happened after you deliver the car to the customer. Then there's the measurement and test equipment cost. And this is the capital cost that you're going to invest. You're going to buy more equipment to test the brakes before you produce. So that cost of buying these equipment to prevent the problems to happen when you are producing, and also to appraise the activities, these are called the measurement and test equipment costs. Okay, you have to memorize these, and to distinguish between them. Okay, so yeah, that's it for me, because I removed many of the slides because they are just related to examples and more details that we don't want to go through. Okay, so this is what you are required to know. Okay, so stop here.